Hey everybody, how you doing? My name is Ray. They call me the Ray of Light, and it's because I shine the light on this incredible future that we have in front of us. Today we're going to talk about what is blockchain. A blockchain is a linked list of transactions stored on a network of computers. Okay? Blockchains are decentralized. Transactions are on a network of computers, and you hear the term nodes, right? They're called nodes. They're immutable. Transactions cannot be changed once committed. They are irreversible, right? There's nobody to call it Bitcoin. There's no Bitcoin support or Bitcoin headquarters, okay? They're open. Transactions can be viewed by anyone. Another amazing thing about this, Etherscan for the Ethereum blockchain. You can look at a transaction at any time, any point, and any kind of transaction. It's all transparent. It's pretty incredible. Now let's get into how blockchains work, right? Each block has a list of transactions, right? A hash, a long string of random characters for the block. The previous block's hash, right? This is how the blocks are linked. It has to have the previous hash, all the other type of algorithmic code and all the other stuff like that, right? Let's take a look at how a transaction works on the blockchain. Suppose Joe, right, wants to send Lisa 1 Bitcoin, right? Let's look at that. You can even see like this. This is a public and a private key. We'll get into that in a little bit. First, both Joe and Lisa need crypto wallets. You both need crypto wallets. These wallets don't actually store crypto assets. Instead, they store 2 keys. Right there, you see them. A public key links to an address that lets you send and receive transactions. Think of it as your email address. A private key proves that you own the tokens associated with your public address. Think of it as your email password. Since a private key is hard to remember, it's a long string of random numbers. Wallets also give you a 12 to 24 word seed phrase. You shouldn't share your private key or seed phrase with anyone. That is very important, right? You have to remember that one right there. We've seen so many people get wrecked just because of that. You don't store it on your phone. You don't take a screenshot of it. You don't write it in a notepad and then save it on your desktop. You don't save it. You write it on a piece of paper and you keep it in a safe or a safety deposit box at the bank. Very important, okay? Bob can send Lisa 1 Bitcoin in 3 steps. Joe tells his wallet, I want to send 1 Bitcoin from my public address to Lisa's public address. Joe signs this transaction based on his private key. This signature proves that Joe actually owns 1 Bitcoin. Joe's wallet sends the transaction to nodes on the blockchain. These nodes then verify the transaction using Joe's signature and public key. A node groups Joe's transaction with other transaction into a block. It then works with other nodes to add the block to the blockchain. Lisa will see 1 Bitcoin in her wallet only after all 3 steps are complete. A block can be added to the blockchain only if other nodes agree. Let's explore how nodes reach consensus next. It's pretty cool. Consensus mechanisms, right? To process transactions without middlemen, nodes need to be able to reach consensus themselves. They do this through 2 popular methods, okay? One is called proof of work. Nodes called miners compete to solve a math problem using brute force. Example, rolling a dice thousands of times to get the right number. The first miner that solves the problem gets to create the block. Other nodes check if the block is valid. If it is, the miner is rewarded cryptocurrency. If it's not, the miner wasted their time and energy. All nodes add the new block to their copy of the blockchain. Proof of work uses energy because miners compete to solve math problems by building powerful machines that run 24/7. Let's look at the other one that's most common. It's called proof of stake. Okay? Proof of stake, nodes called validators stake some cryptocurrency. A stake is like saying, I'll commit this amount of cryptocurrency to win the right to do this transaction. Okay? Validators with more stake are more likely, but not guaranteed, to be selected to process the transaction and create a block. Other validators check if the block is valid. If it is, all participating validators earn a transaction fee. If it's not, the validator that created the block might lose its stake. All nodes add the new block to their copy of the blockchain. Okay? Now, proof of stake uses less energy than proof of work. Bitcoin uses proof of work, and Ethereum is currently transitioning from proof of work to proof of stake. There's something really neat, this triangular thing in blockchain called the trilemma. Blockchains usually have a trade-off between security, decentralization, and scalability. Security, ability to defend from bugs and attacks. Decentralization, ability to support many nodes. Scalability, ability to support a large volume of transactions. Okay, for example, consider Ethereum and Solana blockchains. As of December 2021, Solana's average transaction cost is 0.00025 with 1,000 validator nodes. Ethereum's average transaction cost is $5.20 with 10,000 validator nodes, 10,000 plus actually. The more nodes there are, the less likely it is for a chain to become compromised. This video isn't about what chain is better. Just remember that there is a trade-off and it exists. That's why sometimes you, like I said, you're gonna go and you're gonna look at chains and blockchains differently. That's why you also see who's gonna be the winner and losers with their cryptocurrency. But next, in one of the next upcoming videos, we're going to cover Bitcoin, the most popular cryptocurrency, in the world right now. So thank you for watching. Check it out. Please subscribe, like, and share this video. Have a good one.